here we have two teams independently detecting water vapor, which is, we think, a prerequisite for life potentially on a planet. It's at the right distance that the planets could potentially have life on them. And thus, it's almost like a technology demonstration, is how I would think of it. Like, this is proving that we can detect water vapor at those distances. Now we just need to push it down to smaller sizes, and we're done. And then we can truly find potentially life-bearing planets. But the size thing is a big sticking issue for a lot of people on this.
Size is always important. What's up, you scholars of enlightenment? We're talking astronomy today, and I've got Professor David Kipping back with us. Dave, can you just give the audience a bit of a refresher about your credentials, why we've got you on to discuss astronomy today?
About who on earth is this guy sat in front of you?
Who on earth is a good lead-in, yeah.
Exactly, yeah. So I'm Assistant Professor David Kipping. I'm at the Department of Astronomy, Columbia University. I look for exoplanets, exomoons, and work on a whole bunch of fun space technologies and ideas. So happy to be back on the show.
Excellent. We had Dave on a couple of months back. I'll put a link to that video, which is an excellent video about exoplanets and exomoons, so you guys can go have a look when you like. But today we want to cover two specific stories that I saw on the BBC news website for science. One, that water has been found for the first time on a planet in the habitable zone. And also that a giant planet has been found around a tiny star where it should not exist. So two slightly different but related stories. And I thought, who better to ask on this than my good friend Dave? So maybe if we start with the water's been found on a habitable planet. Yeah. So what's the deal?
Yeah, that was a big story. I've been Twittering and talking to colleagues a lot about that this last few weeks, especially because I have to say, just full disclosure, one of the two teams, this is work by two teams that has done this independently.
Have you got skin in the game there, Dave? Have you got skin in the game?
I've got a little, kind of. My PhD advisor and my PhD institute is one of those papers essentially coming out. So Giovanni Antonetti and UCL was one of the teams. They wrote a Nature paper, and they used publicly available Hubble data to detect water vapor, not liquid water, but water vapor in the atmosphere of a 2.7 Earth radius planet in the habitable zone. I want to be careful with that because it's not obvious what that planet is. Is it rocky? Probably not, to be honest. It's too big, I would say, to be rocky. Is it an ocean world, as the authors were speculating that it might be in the press releases? I guess maybe. We don't really know. We don't really know what ocean worlds would look like. My bet would be that it was a mini gas giant, to be honest. It's a mini Neptune. It's actually closer to Neptune in size. But anyway, it's exciting, detecting water vapor. It's a proof of the technology coming along. And then, sorry, I know there's a lot of details here to get through, but there was also a second paper that came out the day before that paper came out, and it was their data. They took the data with Hubble, and then they realized, I guess, that this Nature paper was coming out, and decided, hey, we need to get ahead of this, and publish their own paper on archive the night before. Yeah. And so there's a lot of controversy for many reasons about this. So it's an interesting story. So we can start wherever you want with this, because there's a lot to say.
In science, we like to say that we're really collaborative and nice, but sometimes it's all about getting that paper out there first ahead of the competition. First of all, well, if we could just step back slightly, what is the habitable zone? Are we just talking about temperature here, or how do we define that?
Yeah. Even the habitable zone is a pretty controversial topic, how you define it. Broadly, what it's supposed to be is that if you put a rocky planet that was somewhat similar to the Earth at a range of orbital separations from the star, it would be capable of having liquid water on the surface in anywhere in that range. And if you put it any closer to the star than the inner edge, then it would be too hot and you'd boil off the oceans. And if you're too far out, you'd freeze the planet over and you'd have like a snowball. So it's supposed to be the Goldilocks zone, where it's not too hot, not too
So it's
not
where
too
liquid
cold.
water can exist on the surface, essentially.
In principle, although of course, Venus is technically in the habitable zone, but it's clearly not habitable. So this is, it clearly isn't just a factor of how big the planet is or how far away is the planet from the star. You have to worry about the conditions of the planet itself. Like, has it got insane volcanism happening on it? Does it have a huge dense atmosphere like Venus does, this greenhouse runaway effect? I mean, maybe even the Earth might be pushed out the habitable zone soon thanks to anthropocentric warming, right? So it's you can't just draw a line in the sand and say everything in here is habitable. But all that being said, it is technically in the canonical habitable zone, as we would call it. Yeah.
So people tend to hand wave and say that it's kind of the area where life will be, probably, if we think about it that way. But in a technical sense, it's actually quite an involved definition. So going on from there, how do we actually detect that there's water vapor in the air? Obviously, we can't go there. We can't take samples. How are we getting these signals that tell us that there's water vapor or carbon dioxide or whatever it might be in the atmosphere of these planets that are so far away?
So these planets are transiting planets, the planets that this kind of work's usually done on. That means that they pass in front of their star, block out some light, and that's how we can tell there's a planet there, just by the star winking at us, basically. And if you look at that winking, that eclipse, in different colors, in some wavelengths of light, the amount of light which is blocked out appears to be greater than other wavelengths. So for the Earth, for instance, the sky is blue, as hopefully everybody has realized at some point in their lives. And if you looked at the Earth transiting,
there's probably a group that says the sky is not blue. We've got the flat.
I'm sure.
Society. I'm sure there's one who will make you question your own sanity. Yeah.
I get those comments on my videos all the time. So anyway, if you looked at the Earth in blue light, passing in front of the sun with a blue filter in front of your telescope, the Earth would appear a little bit larger than if you looked at it with a red filter in front of your telescope. And that's because of Rayleigh scattering, right? The atmosphere is scattering blue light more effectively. And essentially that's what they're doing. They're looking at different wavelengths, and they look at the very specific wavelengths where it is known that water has these vibrational and rotational modes that gets excited at and likes to absorb all of the light coming in, and therefore make the planet look a little bit larger in those wavelengths. So that's essentially what they're doing. They're just sort of measuring the size of the planet, different wavelengths, and they see this like fingerprint of water vapor. It's a very, as you can imagine, it's a complicated measurement to actually pull this off.
So it's spectroscopy, basically, seeing the light that gets that excites those specific modes and is therefore removed from the overall spectrum of the star that's behind. Interesting.
That's right. You call it transit spectroscopy. Is like exactly. That's the name of this.
Just trying to show that I know a few words and know a bit.
You
about
do.
it.
You got the jargon down. Yeah.
I can come to one of your meetings and pretend I knew what I was talking about.
As long as you know the jargon, you can fake it
for 5 minutes. I can hold my own. Excellent. What else? Thinking about looking for life, because obviously people have got very excited. Potential for life if you have pools of water on this planet, potentially. What other molecules would we be looking for if we wanted this to be a good candidate for life? What are the other sort of molecules that we would expect to see potentially?
I mean, I'd almost sort of push you back and say, I don't think anybody's going to be seriously looking at this planet for life,
no.
To be honest with you, despite the headlines. And that's because it is a mini Neptune, right? So it's
been
really
some
hard to
consternation
imagine
about whether it's a rocky planet that's bigger than normal or a mini Neptune. They don't seem to be able to decide, the two groups, which one.
I mean, that's right. And I don't know. This is where things get messy. So the size of the planet and the density of the planet and the mass of the planet would all tell us that it's actually, I would say, very unlikely to be a planet which has a rocky surface and then a thin atmosphere on top of it. I think that's very unlikely. Could it have rock deep down that's then covered with a huge envelope of gas? Yeah, sure. But the pressure level on the surface would be great, like 10 times greater, 100 times greater even, I think was the calculation I saw, than that of the deepest part of the Mariana Trench, you know, off South America. The pressure would just be like ludicrous. The temperature as well. I mean, temperature increases as you go down towards the center of a planet. So all of these things would make complex chemistry basically impossible. So it's, as far, at least the chemistry that we know that's responsible for life. And so if you were going to like handpick which planets do you think are the best for having life in it, we have better candidates than this. This is not.
So
this was not
the only
like
thing that
the
works
best
in
one
this
we
one's
have.
favor is the water and pretty much nothing else, really.
Yeah, I mean, this planet was picked. I mean, the reason it's almost the reason why we know this planet is not likely habitable in the sense that the Earth is habitable, at least, is the fact that the water vapor was even detected in the first place. Proves it. Because otherwise we would not be able to have detected water vapor. So the only reason we detected it is because it has such an extended atmosphere. It has this giant atmosphere. It's a gas giant essentially, and that's why it was possible to detect the atmosphere. If it had a thin atmosphere, forget it. We do not have the ability to detect atmospheres.
So
like
if it was a smaller planet like the Earth or had a thin atmosphere like the Earth, we wouldn't have even been able to detect it in the first place to see the water vapor. Is that the general
exactly. So don't get me wrong. I don't want to like pour too much cold water on this, but see the pun there.
I see what you did there. I like that.
Just that one just came out. So I don't want to pour too much cold water on this, but there are concerns about the way it was publicized and the habitability stuff. I would say just forget that. Just throw all that out the window and just focus on the fact here we have two teams independently detecting water vapor, which is, we think, a prerequisite for life potentially on a planet. It's at the right distance that the planets could potentially have life on them. And thus, it's almost like a technology demonstration. Is how I would think of it. Like, this is proving that we can detect water vapor at those distances. Now we just need to push it down to smaller sizes, and we're done. And then we can truly find potentially life-bearing planets. But the size thing is a big sticking issue for a lot of people on this.
Size is always important.
So yeah, I do know.
I'll leave that alone.
We'll just leave that.
We'll leave that one there. So regarding the technology of going down towards potentially thinner atmospheres, more Earth-like planets, perhaps we're being biased in our looking for life, but that's what we understand as life. Our example here on the Earth. What does the technology look like for getting down to looking at those smaller planets, those thinner atmospheres? Is that something that's coming along? Something where the technology is? Yeah, it's coming. It's the James Webb Space Telescope is the one that we're all excited about as potentially doing this. Is this the one that's been put back year after year after year?
Yeah. I don't know exactly when we're going to see it at this point, but hopefully in the next 2 to 3 years we'll see this thing eventually fly. It's almost like too big to fail at this point. We've poured so much money into it that there's no way it's not going to happen. There's no way it will fail, to be honest, at this point. The thing has been tested so extensively, it's kind of absurd. So I'm very confident that mission will fly and will deliver amazing results. But it's one telescope, so it's not going to be able to look at everything. It's going to only be able to look at a handful of interesting objects, and probably the only planets which it could detect biosignatures on. It's even kind of pushing it for that telescope to do that kind of work. Would be planets which orbit very small stars, so like M-dwarf stars. These are stars which are 1/2 to 1/8 the size of the sun. They are the most numerous stars in the universe. They seem to have lots of planets around them, including rocky planets. The thing that we don't know is, are they truly capable of having life on them? Maybe there's something about those stars that prohibits life. So it's definitely a big stepping point, but we won't be able to do sun-like stars, Earth-like planets around sun-like stars with that telescope. For that, you're talking about even above James Webb, you're thinking about things like LUVOIR, which has recently been, there's a big report that's just been published arguing that this could be the next big mission we should do. HabEx is another example. And these are mostly doing some direct imaging. So they really want to take a photo of a planet rather than do this transit method.
So it's a fast moving area, and there's lots and lots going on. So you'll be in a job for a while yet. That's the message we're getting from
you. Well, I mean, that's the beautiful thing about astronomy, is that we'll pretty much never run out of things to do. This is why I was persuaded not to do particle physics.
I was just going to say, in particle physics, everyone's complaining about, oh, should we bother with the next detector? We didn't really find that much at this energy scale. So maybe... I
was told exactly that advice as a high school student. That I think I asked my physics teacher, I said, if you were going to go into physics now as a researcher, what would you do? And he said, I would do astronomy, because you're never gonna, there's 100 billion stars in our Milky Way alone, right? That's dramatically more than the number of people on Earth. So for every person every person has like 10 planetary systems just to themselves that they can study, right? So it's kind of ridiculous.
The Dave Kipping Federation.
Yeah, exactly. We all can have our own little galactic empires, whereas in particle physics, it's like, whoa, you guys have these huge teams of like thousands of people, and you're like author number 2,367 on that list. And I don't know, that kind of depressed me a little bit. Like, how could you really make an impact as an individual? It's exciting science. Don't get me wrong, but
I typed my H index into like some portal, and it said that I was like the 3rd or 4th most prolific author in Cambridge history or something stupid, because they just put your name on all of the CERN papers. And I'd only worked on like 1, 2, maybe a little bit on a 3rd. Absolutely stupid, but
that's how to do it.
Exactly.
Yeah. Unless you look at like the normalized indices, then you're in trouble.
I'm absolutely.
When they divide by the number of authors.
Yeah, I'm ruined. It's like, it goes back to 1.
Yeah.
That H index was not fit for purpose for me. That was kind of fun thing to say there. Excellent. So with that one, interesting technology demonstration. Good that we can detect these things. Potential higher resolution coming, but we're not talking we found space whales and there's definitely people on this planet. It's been blown out of proportion potentially by the news that like to push these things.
Yeah, I would say the headline might be, if I was writing the headline, I would say maybe it was more like water vapor detected on a mini Neptune in the temperate zone, something like that. That would be like my dialed down version.
It's not catchy though, is it?
It's maybe not punchy enough for BBC, but it's honest. That is what it is, and it doesn't oversell it. So I mean, this is the thing. Some scientists in my field are very worried about this overselling of science, because like we're trying to build LUVOIR, let's say, as the next big telescope that I mentioned, and maybe there's a fear that if we keep saying in these press releases, hey, we're done, we've detected a life-bearing planet, and we haven't, and it's just an exaggeration, then the public will say, okay, well, fine, you don't need any more money for telescopes. So there's also kind of a concern that it will actually just shoot the funding from underneath. If you keep pronouncing that you've done something you haven't really done, A, it's just dishonest. Potentially, you could perceive it that way. If you really exaggerate, it's dishonest. And B, you're potentially killing your own momentum a little bit with the public.
And potentially your own credibility if you're overselling things and then it turns out it's not quite what you said. As you said, you lose that momentum going forwards. No, I think that's
but on the other hand, in defense of the authors, there is a huge amount of ambiguity about what this planet even really is. So you can understand why they could legitimately make the case that this could be an ocean world, because sure, no one can exclude that. It's on the table. It's maybe the more optimistic end of possibilities, some might say. And perhaps if you're going to present that, at least let's put everything out there together. Like it could be a mini Neptune, it could be an ocean world.
And in fairness to the authors as well, I think there's a slight sort of amplitude dialing up that goes when you give it to the journalist as well, where they perhaps put the most grabbing spin on it that they possibly can. So let's be fair to the authors. All right.
We had that, by the way, with the ExoMoon. With our ExoMoon candidate, we announced it as an ExoMoon candidate, and every press coverage about it was pretty much ExoMoon discovery. And we were like, no, that's not what it is. So we've felt that personally. Yeah.